Welcome to the 121st video in our series about Unix tools. In this video, we will look at a mysterious 2012 archive and see if we can get the code stored within it to run. Let's do it. I've already downloaded the archive into this directory, and in 2012 there probably wasn't really XZ, but that's the date we've got on it. We just have to accept that's how it is. First thing we should do is make sure that there's a top level directory inside of the tar file. So we don't extract into the wrong place. Yes, there is. It's a well-structured file. There are 4 pieces of information in there. Looks like a Python, Rex, C, and some kind of shell code. So let's extract it. Just change the T to an X. We've extracted it. And we'll go inside that directory. And we'll take a look at this stuff. And we need to think hard. Of these 4, which one do you think is going to be the easiest to get running? Since this is a Unix system, I think getting the C code to run will be the easiest. But we don't have any idea what's inside of there, so let's take a look. And it says Fred, old school line editor with list, add, delete, save, is left as an exercise for the reader. It's ugly, but it's run, and it's written by yours truly. This archive is left over from a course I taught in 2012. So you can tell I've been here a while. It's GPL, so we can do whatever we want. And look, it gives a hint on how to build it. Can it really be that easy? Is this still going to work? It says this is C99, and everybody knows that's really old, but at least it's not KNRC. At least it's some kind of ANSI C. So the compiler in 2012 was much more primitive than the compiler today. So will the wall extra pedantic find some more errors? I'm not sure. There's only one way to find out. So we give it a try. Oh, look, he's really unhappy. When I made this program in 2012, it didn't give any error messages, but now there's something maybe uninitialized. And it says, warning, pointer may be used uninitialized. May. If you're not a native English speaker, keep in mind that may is not guaranteed. May is some probability greater than 0, but less than 100% normally. So, and it tells you that I used PTR, which is this part, on line 265, and it was declared on line 228, and you can see it's some structure, and I didn't allocate any space, which might be dangerous. So, what should we do? Well, the first thing we should do is run it and see what this thing looks like. And if we crash, and we'll worry about it then. So, what was created? You can see here is the file Fred. It's ELF 64-bit executable. Looks like it's not stripped. It's ready to run. So we try it, and we just get this prompt and nothing else. And so maybe we try H. Doesn't know it. H. Aha. Okay, add a line to the buffer, delete a line, edit. We'll load a file into the buffer. H was our help. L is list, and Q is quit. Well, let's try L. There is no data, but we don't want to crash. And Q, does Q work? Q works. So we've tested the easy stuff. Let's do an E to load some data, and we'll load the Fred.C program. Will load itself. And if we do an L, it scrolled off the screen. Doesn't have any pause anywhere, But with the terminal scroll back, I can see I've got lines 1 through 435. And we need to make some change with this tool to see if it really works. And so it would be nice if we could just list some stuff. So can we do HL to get help on the list? We cannot. So we probably need to take a look at how it's implemented. And this is an example of, we have the source code and it has a license that's permissive. But you notice there aren't many useful comments in here. So it might be tricky. Let's jump to the bottom where we should have the main. We do. You can see the main right here. And here's the prompt we saw. And then it waits for a command. And here is our big switch statement. And you can see the indentation is really awful. But 2012, long time ago. And if we do a set list, you're going to see, oh, I got burned by the tabs, you know. So let's clean that up. So this is from our old VI lectures, which you may have forgotten. It's been quite a few videos ago. Okay, so the tabs are gone. You notice it warns me we're on a read-only file, so I'll have to use the bang to say write it anyway. And then we can take a look at this and we could say, okay, our problem is there. Move that over. These are not quite lined up, but they are now. Save it again. Now, L does the list command. So we need to go back and find the list command function. We're at the bottom of the file, so we'll do a backward search. And there's no comment. I don't think we need the list stuff anymore, so we turn that off. Okay, it does take some sort of range from the get range. Okay, so we need to take a look at what does get range do. Okay, and we take a look. It uses some regular expression. The line range pattern match data. Goodness gracious, where is all that defined? I don't really know. Let's look for line range pattern. Well, it's used a lot. We'll look backwards. And you can see, it's probably this stuff. And of course, some truly hideous looking code. But we learned about regular expressions when we talked about grep. So we should be able to decode this. Okay, the star means 0 or more. So optional spaces, then we've got parentheses, that's a pattern. A plus means you have to have at least one. So some spaces maybe, some digits for sure, maybe some more spaces, then a minus sign, maybe some more spaces, some digits for sure, and maybe some more spaces. And the other pattern is basically optional spaces, digits, and optional spaces. Okay. If you've ever used an old school line editor, which maybe younger people have never seen one, this is behaving like that. We need a smaller file to play with because this 435 lines with no way to pause is tough. So let's make a simple file that we can use for testing. So we'll start Fred and we'll say E simple text. We'll do an L. Now let's try L3. We can list one line. We can list a range of lines. What if we put in a line that's not there? It doesn't crash. And if we go off the end, it just stops. What if we start with a minus line? Okay, if it goes off the other end, less than 1, it just ignores it. So list seems fairly robust, seems to work, and it takes these ranges. And we know the range was a function, so probably all the commands do. Wonderful. And you see this parentheses, which means it can take a range or a single line number. Let's delete line 3, which is this line. And we crashed. So you can see this code has got problems. And we were warned about it when we saw that uninitialized variable warning. And so we've got a segmentation fault, and it says core dumped. And if we take a look, did we get a core? We don't have a core. And if you think back to the GDB videos, you'll know we should check the U limit. And you'll see that the core size has been limited to 0, which means you don't get the core file. So if we want to be able to do this, we're going to have to enable core. And then we can use GDB. So now the core file size is unlimited. We should be able to use GDB, but we have to make the error happen again. So we run Fred, and then we edit simple text. We list it. We delete 3, and we crash. But now we should have a core file. I don't see one. Do you see one? I don't see one. And that's disturbing, because we said, give me a core file. And we look here, I don't see a core file. Let's look in temp. Temp doesn't have a core file. So I still don't have a core file, even though I asked for a core file. Oh. Well, doesn't that just ruin your day? Can we run GDB on Fred? And we get this complicated message. And it's asking to download debug info from somewhere else. No, we don't want to download anything. There are no debugging symbols in Fred. So GDB can't be used for symbolic debugging on Fred because we didn't compile Fred for debugging. Fine, I'll compile Fred for debugging. Why we can't get the core file and do post-mortem debugging, I don't know. But we're not quitters. So let's see how we compiled that. There it is. That's the command we used. So we need to do the same thing as last time, but we need to add the -G. So we get debugging, and probably we want to say optimize for debugging, and then we'll output Fred debug. It says no input files because I forgot the Fred.c. Hard to compile the file if you don't do. We got the same message if you don't include the name. And when we take a look, we'll see Fred is this size, Fred debug is this size. If we do a file on Fred debug, it says with debug info. Okay, now let's go into GDB on Fred. No, we don't want to download anything from anywhere. And it says we still don't have any debugging symbols, and that's because we should have run Fred debug. Okay, finally, we're getting somewhere. Now we're going to run this thing. And it's going to ask that stupid question again. We're going to ignore it again. Okay, the first thing we did was edit the file. So the file name was simple text. Then we did a list. Then we said delete 3. Okay, now we're getting somewhere. And it is that pointer variable, which we got the warning about when we compiled. And it said it may be used uninitialized. But we've got more information. We know that the crash happened in Fred.c on line 365 in the del command function. And then there's some other information, but we don't really care. So let's list 360 through 370. And it says, oh, I don't know that. So we'll just say list 360. And when you list 360, it gives you lines before and after, which is what I was trying to do. So we really want 365. There we go. 365 is in the middle. And it tells you what's going on. We're doing these pointers. Clearly, we're doing some linked list. Okay. Delete some nodes, not either end of the list. Well, that's correct because 3 was in the middle. And so this is a linked list implementation. And we got the pointer t-list next. T-list next is t-list last next. You know, what's going on there? I'm not really sure. But while pointer is not... so this is the endpoint. So while we haven't reached the last line, pointer 2 is pointer. And pointer goes to the next. And then we free pointer 2 next. We set pointer 2 next to null. Then we free pointer 2. And then pointer 2 was null. And you look at that and you say, how can that possibly be right? Because that's just chopping off the end of the list somehow. And we press enter again, and it says decrease the line count and loop. So we set pointer 2 to pointer, and then we incremented the pointer, and we freed the pointer to text, and we freed the pointer 2, and then we loop. So maybe that'll work, but somehow it didn't work for us. So we could set a breakpoint on line 363, and we could run this program again. Okay, let's run the program again. Yes. Okay. Then we do the same thing we did last time. Okay, we've hit the breakpoint. And it lists with this value in the middle here. And it says we're at the top of the loop. So let's print PTR text. And it says 3. So we're right there. We're on 3. So we'll step. Now we're freeing the pointer to text. And it says, I don't have debugging information for that. We're inside, so we'll do an in. And we try a step. And we say, man, what's going on? Try a C. Okay. And C continued until it finished that. And now we're on the next line in the delete command of Fred instead of over here in malloc where we don't want to be and we don't have any debug code. Wow. So we went from 366. Somehow we're back on 365, and that should make your head hurt. And then we step, and we got the seg fault. Man, did that debugging session really help? I don't know. I don't really think it did. So we know it's on line 365. We go into Fred.c, we go on to line 365, and we stare hard. And we say, why didn't this guy give some comments? Okay, let's see what's going on. No comments anywhere. Giant function. So many lines in one function. It's just terrible style. But we go in the delete command, and we have some buffer, and we have some variables. That's not a 1, that's an L. Single letter variable name, bad idea. So, and if you say D, and it says, if there's nothing after the D, you know, if the length of the whole command is D, and it says, are you sure? And if you say you're sure, delete of entire buffer will happen. If you say yes in upper or lowercase, you use the Y. If you don't, then it's not going to do that. It's going to return instead. That's not what we were doing. Okay, if the start is less than 1, valid line numbers must be integers greater than 0. Okay, we didn't hit that error. The end, greater than the line count. We had 5 lines, we chose 3. This did not happen. If you chose something greater than the line count, notice it changes into the line count. But that would have been line 5. We didn't use line 5, so that's not it. If the head of the list is null, so if no file data, if there are no lines of data, we return without an error message. That's not it. So it's got to be somewhere after this. And we're just reading the code, trying to figure it out, because the fool who wrote this, who is now speaking over a decade later, 12 years later, trying to debug this thing. And so if start is 1, well, start was not 1. So we don't think. What did start come from? Go back, start. Okay, start was the first part of the range. And we did not start on 1, we started on 3. So TList is null. TList last is null. Line number, current line number is 0. The pointer is the head, which is actually line number 1. And while the pointer is not null, increment the line number. If the line number is less than the start, the TList is the pointer. If the line number is less than or equal to n, the TList last is the pointer. And then we move the pointer to the next. Whoa. Goodness gracious. So we need to probably, at this point right here, what line is this? On line 321, which is only a comment, so we'd probably have to choose 322. We should take a look at that. If the list is not null, then we jump in here where we crash somewhere. So we should stop on 322, and then we need to investigate what is in TList. Right? I think we do. So we're going to GDB on line 322, and we're going to figure out what's in this TList and work from there. Even when you have the source code, sometimes trying to figure out what they were doing is challenging. Make sure it's where we think it is. It is. It was this if statement. So now we run this thing again. Okay, we've hit our breakpoint. And we say, what is T-list? He says, well, T-list is some structure. Okay, it's a struct A line. It's pointing to a struct A line with that. Well, that doesn't tell me much. Let's try star T-list. Okay, and that says it's pointing at a line with 2, and that's the next line. Okay, and the next line is here. So and you try to look at the next line, you can't really do it. So then you have to go T list next. And T list next is the line 3. That's the one, clearly that's what we want to wipe out. Is this. This is the pointer to the structure, because we couldn't print it this way. We just got a number. But when we printed T-list next, we got the structure we expect. That's the line we want to go away. We'd like to change this value to be this value. That's how linked lists work. We should make the one that has a 2 point to here, because if we look at T-list next, that's the 4. Okay, so that one's pointing to 4. And we should make 2 point to 4. So this number needs to be this number. Yeah, so why is it not happening? So we step. And we check, and, is start 1? Well, let's see, what's start? And it says start got optimized out. Oh, man, what a nightmare. We don't want anything optimized out. So OG is what they tell you to use in the manual. OG was terrible. Let's try O0. And we'll give it another try. Okay, we're going to stop in the same place. We're going to do the same thing. Now the numbers have changed because every time we run the program, the heap is going to point to somewhere else. But the idea is the same. Here's pointing at 2, so this next should get this value right here, so that we'll jump from 2 to 4. And then we need to free that. Okay. Step, and we were going to print start. And hallelujah, start exists, and it is the value 3. Okay, that's the line number we want to kill. And if we list, if start is 1, it says we must update the head of the list. If T-list next is null, no, T-list last next is null. Well, we don't know what T-list last is, so... Okay, T-list last next is null. That's going to be false. Okay, that's not true. We are not going to line 327. And we didn't. We went to line 345. So at 345, we have to ask, the same question. Is it null? I don't think we changed anything, but we can certainly look at it again. T-list last next is not. Is it null? No, it is not. So if we step, we are not going to go here. And we didn't. Does this line look pretty familiar? It should. We're here. So we're going to step again. Step again. At this point, we should see what is PTR and what is T-list. Okay, PTR is the one that's 3. And T-list is 2. Okay, T-list is 2. And PTR is 3. So we ask, is PTR, the pointer PTR, different from T-list last next? Well, you know, I don't know. T-list last next is that. PTR is that. They are not the same. This is 1210, this is 1250. They are not the same. So if they're not the same, this will be true. We're going in the loop. We should go to line 364. And we do. And we set that. So now if we print PTR and we print PTR2, they should both be pointing here. And that is the line with 3. Okay, let's list. We are on line 365. Yes, we are. We're on this line. And we're going to free pointer to text. Okay, and pointer to is this one. So what's pointer to text? Uh-oh. You know, what's going on? And you say, I can't get to that. Okay, pointer to text is 3, and we want to delete that. So this should work. And of course I stepped into the free, so I got to do a continue. And I got the segmentation fault on line 366 when I tried to free that. When I tried to free the 3, it killed me. So we're going to break on 366. We're going to run again, starting from the beginning. Oh, I spelled it wrong. See, every time you spell it wrong, it's going to jump into here and go nuts. So run. That's another bug. You know, we should not call an abort when you give a bad file name. This code is really horrible. Okay, we list. We're going to delete 3. We're going to continue from that one. Now we've hit the second breakpoint, 366. And if we print star PTR2 and we do star PTR2 text, which starts on that, which is the 3. And if we try to free that right here, it's going to, it appears to be determined to crash. And it doesn't crash. Does that make your head hurt? It should. When we single stepped in, it crashed. When we don't single step in, it doesn't crash. So before we do the free PTR, let's see what PTR2 is. And it says it's a structure pointing here with no text. Why is the text 0? Because we set it to 0. So we should be able to free this. And if we do a next, we freed it. And we set it to null. And we decrease the line count. So if we print line count, it should say 4. It does. And when we look at PTR, it's pointing to that number, which was the next here, which we wanted. So if we print PTR, that's line 4. We're on line 4. What is this? What? What? You know, the T list last next is pointing into La La Land. It's pointing into La La, into nowhere. You notice all these other pointers start with a bunch of 5s. And this guy just has, you know, silly stuff in the front. It's not anywhere near the rest of them. And so now I think we know what the problem is. T list last next is pointing to nowhere. And if we just say print T list last, T list last is pointing into nowhere also. And so when we come up to the top of the loop here and we try to evaluate this condition and we look at PTR is fine, it's line 4. But this T list last is just garbage. And that's why we're crashing. They're not equal, but I mean clearly this is garbage. Would you agree with me? I know you would. So, wow. Why is that junk? Where did we change it? Where did we do anything that was gonna cause a problem? So let's list from about, say, 358 and see what we've got. T list last next, which was here. So on 362, T list last next may have been junk when we set this T list. So we've got a breakpoint on line 363. So let's run it again and we'll check T list last next and we'll see if it's junk or not by looking at T list next. So we look for some pattern like that. Okay, run. Restart from beginning. Oh yeah. Type in the correct file name, list it, delete 3, hit your breakpoint, which is on 322. That's not the one we care about, so we continue to the next, this breakpoint we care about. And we said, well, what is pointer? Pointer is the one that's 3. T list last. T list last is also 3. And T list last next is here. which is the 4. What is going on? Okay, so list 363, where we are right now, and we take a look in here and we say, how is this broken? Okay, we're looking at T-list last next. We never changed that. What about T-list next? Did we change that? Take a look. We changed pointer 2 to pointer, and we did that stuff which should be fine to pointer 2. Okay, and we moved pointer to pointer next, and that's all we did. But somehow this got corrupted anyway. Okay, we're at the breakpoint on 366, which is here. Pointer 2 is fine. Pointer 2 text is fine. It is the word 3, which we want to go away. Let's take a look at T-list just to make sure it didn't go nuts. T-list is 2. It's still pointing to the 3. And T-list next. Okay, T-list next is pointing to 3, and it really shouldn't be, but it is. It's pointing, and that is also should be the same as T-list last. It is. Wow, that just okay, we're back at the top of the loop again. So let's print head. One, 2, 4, 5, and the last one is a null. So the list has the correct data in it. At this point, the list is correct. It's valid. We start at head. We get 1, 2, 4, 5. And that's the whole list. So the list delete has finished. It's done. It's okay. But somehow PTR, which we think should be pointing to 4, and T-list last next, PTR. PTR is pointing to 4, like it should. T-list last has gone insane, and it's pointing to just random memory at this point. So T-list last got scribbled. That's what we call it. It got scribbled. Somebody wrote some memory on top of it, and the memory that they wrote is junk. And so when you compare the good pointer to junk, it just won't work. We set T-list next to T-list last next, and it was okay. And that's still 4. But then you see we use this. We're probably supposed to use that. So it looks like the bug is on line 363, and after carefully saving this someplace, we didn't use it when we should have used it right there on line 363. Is that going to fix the bug? Let's find out. So we'll This is old stuff. So we'll comment that out. And we'll try using tlist.next or tlist arrow next and see what that does. And we don't want to change the line numbers of everything. So we'll say was. It was that. We'd have to recompile it again. And this time we want to recompile with O0 because OG still optimized stuff out. We make sure we've got debugging turned on. Moment of truth, people. We fixed D, it looks like. But that was a D with just one number. So let's quit. Let's try a delete with more than one number, but in the middle of the list, which was the code we're using. So let's edit simple text. Let's do a list, and let's delete, say, 3 through 4. So if that works, we should have 1, 2, 5. 1, 2, 5. That worked. So we've deleted a single one from the middle, it worked. We deleted a range from the middle and it worked. Now we need to delete each endpoint, and then we need to delete a range that starts at the beginning, a range that ends at the end, and then finally delete everything. If all those deletes work, we'll have fixed the bug. So we've tested just delete 3. We've tested delete 3, 4. Let's delete 1 through 3, and that should leave 4, 5. It does. And notice I'm restarting each time fresh because that's the easiest repeatable way to do this. Now let's delete 3 through 5, which is a range that goes to the end of the list but not the beginning. We got the 1, 2 as expected. One through 5 should, let's list first. And then we'll delete 1 through 5, which is the whole range. No crash. Okay. This kind of debugging, a lot of people don't like doing it because, it's slow. But this is how if somebody had done this the first time, we wouldn't have all these problems. Deleting the last one works. Deleting the first one works. There was also, in the source code, we saw there was a special case for just D. Are you sure? Yeah. Okay, all the deletes have been tested, and they all seem to work. But, yes, that's right. One of you in the audience spotted it. What if you were evil? And somebody will be evil. Ooh, 3 to 3. What's that gonna do? It works. So you think this code is ready, do you? Let's see. Let's delete 4 through 2. What's that gonna do? But that's not really a linked list problem. That's a problem where the code fails to check that the range end is greater than or equal to the range beginning. That's a different bug. Okay, but it shows that this code is not thoroughly tested. And it's pretty easy, if you think of every possible case, to kill it. But it's better than it was. We did fix the first bug that we found, and we fixed it using GDB, even though we couldn't get the post-mortem stuff to work, because although we said U limit minus A, unlimited core size, we weren't getting a core. And we still don't have a core. There's something else in this Ubuntu system that's preventing the core dumps. And I don't know what it is, so that'll be in a different video. Clearly, Ubuntu has done some extra safety security for us that is preventing the core dumps. But when you want the core dump, it would be nice if you could get it. And I will find out what that is and cover it in another video. On a normal Unix system, if it says segmentation fault core dump and your U limit minus C is unlimited, then you will get a core file somewhere. But we didn't get one. Okay, we can remove Fred debug. He's done his job. We can remove Fred. We can go back into Fred.c and we can say, wow, that was pain. And it was around 365 somewhere. We can remove this comment because that bug is fixed. Okay? And the problem was they carefully saved this and then they used it anyway. And they were supposed to use the saved one, not this one. Now, why is this one moving around? I don't want to know. Okay? We fixed that bug. So where is the other bug? The other bug has got to be something about the range. Okay? Here we get the range. We take the start and the end. We check if the start is less than 1. We check if the end is greater than the line count. What we didn't check was, is range insane? So if end less than start, right? That's the problem. If the end is less than the, if the end is equal to the start, that's like 3 to 3. We tested that worked. If the end is less than the start, that was where we had the problem. Uh-oh. Indentation body. Printf. And what are we going to say? End of range cannot be less than start of range. I think that's correct. Okay, fix the permission on that so we don't have any more and let's fix the permission on all these silly files so we don't have any more trouble. All right, we can write them. We're the developer. It's our file. Let's compile and let's follow the compile instructions that we had originally. I'm feeling pretty brave. We still get the warning. We still get the warning, but I'm going to ignore that. And the case that failed was when we did an E on simple.txt and we said delete 4 to 2, right? And that's what crashed I think last time. Yeah, delete 4 to 2, and we got a segmentation fault core dump. So we're trying it again. And we've got our message. End of range cannot be less than start of range. Is that going to break the 3-3 test? No. What if you do it at the beginning of the list? It's okay. End of list. It's okay. The whole list. It's okay. That's a little stupid. Okay. End of range cannot be less than start of range. And there is no range, really. There are no lines at all. So we have the right test in the wrong place. But at least we can laugh about it. So we go back and we look at that again and we say, you know, all this trouble for delete. Maybe we just shouldn't allow delete. It'd be a lot easier if we didn't allow delete. End of range cannot be less than start of range. And then I check if head is null. Well, let's check that first. What do you say? Okay. And careful testing, you'd have to test every test case every time with automated testing. And you'd learn that in a software engineering course. But this is not a software engineering course, so we're not going to do that. But I don't want people to think, gee, he doesn't even know. Okay. So what happened was we deleted everything. And then we said delete from 3 to 3. Okay, now we don't get any message because there's nothing to delete. Some tools would complain and say, oh, invalid range, you know, no such line number 3, but really we don't care. That's delete. We've worked hard on delete. Does add work? I don't know. Add line to the buffer. We'll just type A. Okay, enter a period on a line by itself to terminate add mode. At least we got some instructions. Hi. This editor is very buggy. Okay, there it is. We got the line. Can we add again? Add. Looks like we can. And we're going to add nothing. Ooh, did that break it? Seems to work. Okay. I want to add before line 1. Can I add at 0? Yes, I can. Can I add at 3? Can I add it at 3 again, which should come between 3 and 4 that you see on the screen? Yes. So add seems to work. Let's try something really stupid. Okay, those were, I admit it, pretty stupid. Oh, invalid command because I did a lowercase. Okay, now we've done a lot of different kinds of adds. What if we add a range? What's that gonna do? And you can see it pretty much just ignored the rest of that. Probably it should have a message, but it doesn't. We've tested add, tested delete, we've tested E to load the file, we've tested H, we've tested L, and we've tested Q. I feel pretty good that we debugged Fred, the C version. Now, can you find more bugs? I'm sure you can. But we've gone through debugging Fred C. This video is now 1 hour, so I'm going to stop. And when we come back, next video, we'll tackle Fred.py. And I might have an update on the core dump issue. Until then, I hope you relax and you learn something from watching the debugging session, and I try to speak my logic as I go. We took random C code from 12 years ago, debugged the code. We didn't clear up the warning yet, but we at least debugged 2 bugs in the delete code using GDB as an helper tool. Thank you for listening.